All of us have looked at and held paper money, such as our present Federal Reserve notes, but how many of us have wondered about the measurements used to create those bills? Why did the money architects use those proportions and not some others? When I began to look into this question, the first thing that caught my attention was how strange the choice was for the length and width of our present bills. 6 and 14 100th inches by 2 and 61 100th inches. I'm sure that most builders and designers would agree that in a nation with the inch as its basic unit of measure, it does seem a bit odd to have divided it into hundredths of an inch. Normally, the inch is divided into halves, quarters, eighths, sixteenths, and so on. Now, aside from any other agenda, 6.125 inch by 2.625 inch would have made much more sense. A bill this size would be practically indistinguishable from our actual bills, since both pairs of measures correspond to better than 99%. What's more is that the perimeter of this hypothetical bill is identical to the actual bill's 17.5-inch perimeter. Dividing 17.5-inch into 6.14-inch and 2.61-inch increments is certainly an obvious incongruity, but by now we should know it hadn't been done for a reason. And for that reason, we have to look at the size of the notes prior to 1929, when the stock market crashed, banks failed worldwide, and the Great Depression took hold. That's when our paper notes shrank to the size they are today. The year 1862 marks the date of the first U.S. government-issued legal tender note. Its designed length was 7.425 by 3.125 inches. Though tolerances varied over the many years of printing, these notes remained nominally this size until 1929. Originally, each paper note was backed by gold or silver, held in reserve, and was redeemable for such on demand. The paper facsimile was simply more convenient to carry around, and after time gained preference over the actual metal. The Coinage Act of 1792 made the silver dollar the foundation of the new nation's monetary system, stating that each was to contain 371 grains and 4/16 parts of a grain of pure silver. So each half of a note's length enshrines in number the essence of what is a dollar's true value. At this point in my studies, I had come to conclude that whoever designed the paper notes, for whatever reason, transposed the defining properties of the actual gold and silver coins into their paper representations, with the first clear example of this in their 7.425-inch edge length. From the first notes to this day, they are printed 32 per sheet of paper, arranged as 8 widths by 4 lengths. So regarding these old large notes, each paper's printed face measured 29.7 inches by 25 inches, and equaled an area of 742.5 square inches, which we now recognize as 2 times 371.25, which again is the precise number of grains of pure silver contained in a silver dollar. To add another dimension to this mysterious conspiracy is the fact that 742 square inches is also equal to 5.15625 square feet. In this quantity, we can see the 0.515625 portion of a troy ounce of pure gold, which is equal to the 247.5 grains called for in the 1792 Coinage Act. So the sheet of printed paper, which mimics the essence of the silver dollar, is also related directly to the $10 eagle. From 1834 until 1933, 1 grain of gold equaled 16 grains of silver. Previous to that, it was 15 grains. This meant that a dollar's worth of gold weighed 23.20 grains, which again is numerically embodied in the 23.203125 square inch surface area of these large notes. And the 16:1 ratio is also hidden in the occult paper design. It was shown previously the area of one large note is 23.203125 square inches. And if this were grains of gold, it would be equal to $1. 16 of these notes equal 371.25 square inches. And if instead of inches were grains of silver, that would equal $1. And lastly, for now, the length of these large notes is directly related to our measures of land. At about the same time the Coinage Act established the monetary system of the United States, vast areas of the American states were divided up into townships, which measure 6 miles by 6 miles. 51,200 old large notes, laid end to end, precisely measures 1 6-mile edge of a township. And the surface area of these 51,200 notes, multiplied 5.280 times, which is the power of our familiar mile, exactly equals that of 1 acre. Part 2, the transition to smaller notes, is coming soon. If you have found this video of interest and of some value, please click the like and subscribe icon below. And for more unequivocal evidence of the Illuminati using simple mathematics and geometry to manipulate our societies from behind the scenes, read my book, The Geometry of Money, online free at my website, kasperskyart.com. Hard copies are also available for purchase. They're $20 each, $10 shipping via U.S. priority mail. Just mail Paul at kasperskyart.com to place an order.